This is my 68th episode on the Cosmology series of talks, and my subject today is Earth's axial tilt, the tilt of the Earth. In astronomy, axial tilt, also known as obliquity, is the angle between an object's rotational axis and its orbital axis, or equivalently the angle between its equatorial plane and orbital plane. It differs from orbital inclination. In the case of Earth, the axis is tilted towards the ecliptic of the Sun at approximately 23.44 degrees. This tilt in Earth's axis is what is responsible for seasonal changes during the course of the year. When the North Pole is pointed towards the Sun, the Northern Hemisphere experiences summer and the Southern Hemisphere experiences winter. When the South Pole is pointed towards the Sun, 6 months later, the situation is reversed. In addition to variations in temperature, seasonal changes also result in changes to the diurnal cycle. Basically, in the summer, the day lasts longer and the sun climbs higher in the sky. In winter, mostly the days become shorter and the sun is lower in the sky. In northern temperature altitudes, the sun rises north of true east during the summer solstice and sets north of true west, reversing in the winter. The sun rises south of true east in the summer for the southern temperate zone and sets south of true west. The situation becomes extreme above the Arctic Circle, where there is no daylight at all for part of the year and for up to 6 months at the North Pole itself, known as a polar night. In the Southern Hemisphere, the situation is reversed, within the South Pole oriented opposite the direction of the North Pole and experiencing what is known as the midnight sun, that is a day that lasts 24 hours. I got a video animation on the axial tilt of our planet Earth. I'm going to roll the video right now.
Along the orbit of the Earth around the Sun, the angle at which the sunlight reaches the Earth varies. In summer, the sunbeams reach the surface at a more pronounced angle than in winter, resulting in higher temperatures. In winter, the solar energy is more widely dispersed, as the rays reach the surface of the Earth at a lesser angle, resulting in lower temperatures.